Our sun, the star that fuels life on Earth, is a powerful force of nature. It constantly emits light and heat, but sometimes it unleashes its fury in the form of solar storms. Imagine a sudden burst of energy, a massive eruption of charged particles, a constant stream of solar material hurtling through space. These are the hallmarks of solar storms, events that can impact our planet in both awe-inspiring and disruptive ways. Solar storms are a fascinating phenomenon, born from the complex interplay of magnetic fields within the sun. These storms are not just a spectacle, they are a reminder of the sun's immense power and its potential impact on our technological civilization. Understanding solar storms is crucial, as we become increasingly reliant on technology that is susceptible to these cosmic events. Just like a summer thunderstorm on Earth, a solar storm is a disturbance in the sun's atmosphere. But instead of rain and wind, a solar storm involves intense bursts of energy and particles. These outbursts can travel millions of kilometers through space, sometimes reaching Earth and interacting with our planet's magnetic field and atmosphere. Solar flares are one of the most dramatic manifestations of solar storms. Imagine a sudden localized brightening on the sun's surface, releasing a tremendous amount of energy in the form of light and radiation. This is a solar flare, a sudden burst of intense brightness, often near sunspots, indicating a release of magnetic energy. Solar flares are classified according to their brightness in X-rays, with the most powerful flares categorized as X-class flares. These intense bursts of energy can disrupt radio communications on Earth, interfering with signals used by aircraft, ships, and other communication systems. Solar flares are short-lived, lasting from minutes to hours, but their impact can be felt almost instantaneously on Earth. The energy released during a solar flare is equivalent to millions of hydrogen bombs exploding simultaneously. This energy travels at the speed of light, reaching Earth in just over 8 minutes. While most of this energy is harmlessly absorbed by our atmosphere, the most intense flares can cause disruptions to our technological infrastructure. Coronal mass ejections, or CMEs, are another type of solar storm that can have significant impacts on Earth. Imagine a giant cloud of solar plasma containing billions of tons of material being ejected from the sun's atmosphere. This is a CME, a massive burst of solar wind and magnetic fields rising above the solar corona and released into space. CMEs travel much slower than solar flares, taking 1 to 3 days to reach Earth. However, their impact can be much more significant. When a CME collides with Earth's magnetic field, it can trigger geomagnetic storms, disrupting satellites, power grids, and communication systems. The sheer scale of a CME is mind-boggling. These eruptions can span millions of kilometers, dwarfing the Earth in comparison. When a CME reaches Earth, it interacts with our planet's magnetic field, causing it to compress and distort, leading to a cascade of effects that can be felt on the ground. Section 4. Solar wind, a constant stream of particles. Unlike solar flares and CMEs, which are sudden and explosive events, the solar wind is a constant stream of charged particles flowing from the sun. Imagine a continuous flow of protons, electrons, and alpha particles streaming out from the sun in all directions. This is the solar wind, a constant outflow of charged particles from the sun's upper atmosphere. While the solar wind is generally harmless, it can become more intense during periods of high solar activity. This intensified solar wind can compress Earth's magnetic field, leading to geomagnetic storms and auroras. The solar wind is a constant reminder of the sun's influence, shaping the space environment around our planet. The solar wind travels at speeds of hundreds of kilometers per second, carrying with it a piece of the sun's atmosphere. This constant flow of charged particles interacts with Earth's magnetic field, creating a dynamic and ever-changing space environment that can impact our technological systems. Section 5. The Fury Unleashed. Impacts of solar storms. Solar storms, with their bursts of energy and charged particles, can have a wide range of impacts on Earth. The most visually stunning effect is the aurora borealis and aurora australis, vibrant displays of light in the sky caused by charged particles interacting with Earth's atmosphere. These dazzling displays of light, often seen in high-latitude regions, are a beautiful reminder of the sun's influence on our planet. However, solar storms can also disrupt technology, potentially affecting communication systems, navigation systems, and power grids. Intense geomagnetic storms, triggered by CMEs, can induce currents in power lines, leading to widespread blackouts. Satellites, vital for communication and navigation, are also vulnerable to solar storms, as the intense radiation and charged particles can damage their sensitive electronics. Even human health can be affected by solar storms. Astronauts in space are particularly vulnerable to the increased radiation levels during solar events. While Earth's atmosphere and magnetic field provide significant protection, solar storms can still impact aviation, increasing radiation exposure for passengers and crew, particularly on high-altitude flights. Section 6. The importance of understanding solar storms. As we venture further into the space age and rely increasingly on technology, understanding solar storms becomes ever more crucial. From protecting our astronauts in space to safeguarding our critical infrastructure on Earth, predicting and mitigating the impacts of solar storms is a vital area of scientific research. Monitoring the sun's activity, developing early warning systems, and designing resilient technologies are crucial steps in protecting our technological civilization from the sun's temper tantrums. Solar storms are a reminder that we live in a dynamic and interconnected solar system. The sun, our life-giving star, is also a source of potential disruption. By understanding the nature of solar storms, we can better prepare for their impacts, ensuring the safety of our astronauts, the resilience of our technological systems, and the continued exploration of our cosmic neighborhood.
A heatwave is a prolonged period of excessively hot weather, which is relative to the usual weather of an area. Heat waves are characterized by high temperatures, sometimes reaching record highs, and they can last for days or even weeks. Often accompanied by high humidity, the heat during these periods can feel even more intense. Heat waves are becoming more frequent and intense due to climate change. As global temperatures rise, heat waves are more likely to occur, posing a significant threat to human health, infrastructure, and ecosystems. Understanding heat waves is crucial for adapting to our changing climate. Heat waves are not just a minor inconvenience, they can have deadly consequences. Thousands of people die every year from heat-related illnesses during these periods. The elderly, the very young, and people with pre-existing medical conditions are particularly vulnerable. Additionally, heat waves can trigger wildfires, strain power grids, and damage crops, further illustrating their severe impact on our society and environment. High-pressure systems are one of the main causes of heat waves. These systems trap heat near the surface of the Earth, preventing it from escaping into the atmosphere. This leads to a buildup of heat, resulting in a heat wave. High-pressure systems are often associated with clear skies and calm winds, which further contribute to the warming effect. Urban areas, in contrast, are often hotter than their surrounding rural areas due to the urban heat island effect. Cities have large amounts of concrete and asphalt, which absorb and retain heat. Additionally, the lack of vegetation in urban areas reduces shade and evaporative cooling, making cities particularly vulnerable to heat waves. The combination of high-pressure systems and urban heat islands can create dangerously hot conditions, especially in cities located in regions prone to these high-pressure systems. These conditions can put a severe strain on public health systems and infrastructure, highlighting the urgent need for effective urban planning and adaptive measures to mitigate the impact of extreme heat waves. Section 3. Impacts of heat waves. Heat waves can have a significant impact on human health. Heat stroke is a life-threatening condition that occurs when the body's temperature regulation system fails. It can cause organ damage and death. Other heat-related illnesses include heat exhaustion, heat cramps, and heat rash. The elderly, young children, and people with chronic illnesses are at increased risk of these conditions. Agriculture is also affected by heat waves. High temperatures can damage crops, reducing yields and increasing food insecurity. Heat stress can also harm livestock, leading to reduced productivity and increased mortality. Heat waves can exacerbate drought conditions, further stressing agricultural systems. Heat waves can have a significant economic impact. High temperatures can reduce worker productivity, especially in outdoor industries like construction and agriculture. Heat waves can also increase energy demand for cooling, straining power grids and leading to blackouts. The economic costs of heat waves are likely to increase as climate change intensifies. Section 4. A look into the future. As global temperatures continue to rise, heat waves are projected to become more frequent, intense, and longer lasting. This will have profound consequences for human societies and natural ecosystems. Heat waves will pose an increasing threat to human health, food security, and economic stability. Adapting to a hotter world will require significant investments in infrastructure and public health. Cities will need to implement strategies to mitigate the urban heat island effect, such as increasing green spaces and using reflective materials in construction. Early warning systems and public awareness campaigns will be crucial for reducing heat-related illnesses and deaths. Failing to address climate change will lead to a future marked by extreme heat waves and their devastating consequences. The choices we make today will determine the severity of the impacts we face in the years to come.